Hello, welcome to your first lesson in physical science. Today we are going to be discussing matter. So let's get started. Sharing my screen with you and our presentation will begin. Okay, I'm going to minimize myself so you can see the whole screen. And I'm going to put my tools up in case I need them. So we're going to talk about describing and classifying matter. And our essential question is going to be, how can we observe, measure, and use matter? And all of these pictures are things that we're going to become familiar with throughout this unit. So our science standards that we're going to be working with this entire year are the following: asking questions and defining problems, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational thinking, constructing explanations and designing solutions, and obtaining, evaluating, and communicating information. So we're going to be doing these throughout the whole year, so you're going to become familiar with them, as well as they are the ones, the standards from last year that were on your report card. There is also going to be substandards. So today's substandard is going to be PS1, Physical Science 1, develop models to describe the atomic composition of simple molecules and extended structures. So we're going to begin that process today to learn about these things. Here are the objectives from today, and pay attention to them because at the end of the lesson, your homework is going to be to answer these objectives. So this is a longer lesson, so halfway through, I'm going to say that you should pause it, take a break for a while, and then come back to the second half. So the objectives are: I can explain what matter is, I can explain what a substance is and give an example of a pure substance and a non-pure substance. I can describe the two properties of matter and give 3 examples of each property. I can label the parts of an atom and explain the particle theory of matter. I can explain what an element is and give 2 examples. I can explain what a molecule is and give 2 examples. I can explain what a compound is and give 1 example. I can define a mixture, name 2 types of mixtures and give an example of each type. I can explain the differences between a compound and a mixture. And finally, I can explain the 4 methods for separating a mixture. So let's get started. So first of all, what is physical science? Your whole year you're going to be learning about physical science. So physical science is the study of the non-living world. Last year in 7th grade, you covered studying the living world. So physical science is the study of matter and energy and the changes they undergo. So we're going to be discussing matter for the first trimester, and then we're going to move into things about energy. So what is matter, since we're going to be talking about it for an entire trimester? So let's take a look. Matter is anything that has mass and takes up space. So whenever you see this little pencil mark, that's a good pausing point in the video for you to write down and take notes from the lesson. Taking notes is going to help you tremendously. So this would be a great pausing point whenever you see this pencil. Okay, let's talk about matter some more. Here are some examples of matter. I should say matter, not matters. There are many, many, many more examples of matter than what I'm going to show you here. So wood is an example of matter because it has mass and it takes up space. Metal is an example of matter because it has mass and it takes up space. Paper is an example of matter because it has mass and, it takes up space. Glass is an example of matter because it has, mass and takes up space. Memorize this definition. How about cloth? That is matter because it has mass and it takes up space. Air, believe it or not, is also matter because it has mass and it takes up space. You might say, what? Well, think about blowing up a balloon. When you blow air into the balloon, it gets bigger. So the air is taking up space. It's making the balloon stretch and get bigger. So air is matter. And finally, you are matter. Not only are you matter, but you do matter. So you have mass and you take up space. Okay, what do we know about matter? Well, we know that matter can be a solid, a liquid, or a gas, and you must have learned that in your previous grades of elementary science. Matter can be visible or invisible. Think of air. Air is invisible, but it's matter. And matter has different properties. So what is a substance? Another note-taking opportunity here. A substance is a single kind of matter that always has a specific makeup or composition. It's always the same. So for example, sodium chloride is a substance. Do you know what sodium chloride's common name is? Well, there it is on the right. It is salt. You're going to get to know some chemical names of some common products as well. So it's always going to be salt. It has a specific makeup and composition. Why is sodium chloride salt a substance? Well, I already told you. Sodium chloride is a substance because it always has the same ingredients. Sodium chloride is a pure substance. No matter if you look at a single grain of salt or a boulder of salt, it is still salt. So it is a pure substance. A pure substance has a constant composition. That means it always has the same ingredients and it has unique chemical properties. Is sea salt a pure substance? We said salt was a pure substance. What about sea salt? Sea salt is not a pure substance because it is formed from evaporated seawater. Seawater has many other substances in it, as you can imagine, and when the water evaporates, it leaves behind sodium chloride plus many other ingredients. So that's why if you go to the store, it's better to buy sea salt than regular table salt because sea salt has a lot more minerals and things that are good for you. So always try to buy sea salt, but it is not a pure substance. Pure substances and non-pure substances. Let's look at the difference. Pure substances and non-pure. So here are some pure substances. Gold is a pure substance. Diamond is a pure substance. Both of those are very expensive, by the way. And nitrogen gas is a pure substance. What about non-pure substances? Lemonade is non-pure because it's a mixture of different things, right? It's water and lemons and sugar and whatever else you might put in there. Chocolate is a non-pure substance. That's a mixture of different things. And a bowl of nuts is a non-pure substance. It is not pure. It has many different things mixed in. What are the two properties of matter? You're going to want to know these two properties. So there's a little pencil again on the left. Physical property is a characteristic that can be observed without changing the matter into another type of matter. So the key word here is that it can be observed and it doesn't change into another type of matter. So can you see what you can see, hear, feel, smell, touch, measure? What are some physical properties of matter? Can you think of some? Melting point is a physical property. You can actually see when it melts, and it will always be the same for a certain substance, right? Different substances have different melting points. Color is a physical property. It's something you can see. Malleability is a physical property. That's the bendability of something. Boiling point is also a physical property. You know, when something boils, a certain type of matter will boil at a certain boiling point. Shininess is a physical property. Conductivity is a physical property. So if something is very conductive, that would be like copper wire would be very conductive. That lets electricity through very easily. And some other types of matter may not. Think of rubber. That does not let electricity go through. very well at all. So that has low conductivity, but that is a physical property. And the phases of matter are physical properties. So the state of matter, is it a solid, a liquid, or a gas? That's a physical property. Okay, what are the two properties of matter? We talked about physical properties. The second is chemical properties. A chemical property is a characteristic that describes something's ability to become something else. So what does that mean? Here are some chemical properties. Reactivity. How well does it react to other chemicals or other substances? That's a chemical property. Coordination number. That is a chemical property. Flammability is a chemical property. What's flammability? How quickly or how easily something burns. Chemical stability is a chemical property. Combustion is a chemical property. And oxidation states is a chemical property. And finally, toxicity is a chemical property. So you have to decide, is this a chemical or a physical property? Oxygen is a substance that dissolves in water. Fish absorb oxygen from the water. Is dissolving a physical or a chemical property? Dissolving, a physical or a chemical property? What do you think? Well, here is your hint. Does the oxygen change into another substance when it's dissolved? If yes, dissolving is a chemical property. If no, then it is a physical property. Do you have the answer? There it is. It is a physical property. Did you get it right? Good. Let's go on. Okay, what about this one? Water and carbon dioxide in the leaves of the coconut palm tree are converted to oxygen and sugar by photosynthesis. Is photosynthesis a physical or chemical property? Hint, does the water and carbon dioxide change into another substance? If yes, photosynthesis is a chemical property. If no, then it is a physical property. What do you think? Did you guess chemical property? All right, great job, because you're changing the water and the carbon dioxide into a food for the plant. So it's changing into something else. Here's another one. If iron is exposed to air and water, it will rust. So is rust, does the iron change into another substance? When it rusts, does it change? If yes, rusting is a chemical property. If no, then it is a physical property. What do you think, chemical or physical? That is a chemical property. The rust changes into something different. The iron is no longer iron. It is now a different property, a different form of matter with a different property. Okay, what about this one? Wood is hard and inflexible, especially when it's been dried. Physical or chemical property? Hint, does the wood change into another substance? If yes, hardwood is a chemical property. If no, then it is a physical property. Which one? Did you say physical? All right, it is a physical property. Hopefully you're getting these. You're going to have a little bit of a test on this, or a quiz, so to speak. What is the particle theory of matter? Another note-taking opportunity. The particle theory of matter explains that all matter is made up of very tiny particles called atoms. All pure substances are made of their own kind of particle. All particles are moving, and particles at higher temperatures move faster than those at lower temperatures. We'll be discussing that later on in the year. And particles are attracted to each other. We'll also be discussing that a little bit later too. What is an atom? An atom is the basic unit from which all matter is made. There are different types of atoms, but everything you can think of is made of atoms. And atoms are very, very tiny. They are so tiny that this is how many atoms are in 1 grain of sand. I don't know what that number is, but it's huge, right? So I could try to figure it out, but for sake of time, I'll let you do that, figure that out on your own. But it's very, very huge amount of atoms on 1 single grain of sand. That's how small they are. So what are the parts of an atom? Here's an atom. So the nucleus, there's the nucleus. The nucleus of an atom is the small, dense region of the center of an atom that contains protons and neutrons. Almost all of the mass of an atom is located in the nucleus. There's your proton inside of the nucleus. The protons are positively charged and they help bind the nucleus together. They also attract electrons and keep them in orbit around the nucleus. The number of protons in an atom's nucleus determines which chemical element it is. There's a neutron also located in the nucleus. The neutrons have no charge, they're neutral, that's why they're called neutrons, and they live in the nucleus. Neutrons play a major role in the mass and radioactive properties of atoms. And finally, the electron, which is on the outside of the nucleus. The electrons are negatively charged and they are extremely small compared to all the other parts of the atom. So we already know how small an atom is, so think how small an electron is. Electrons play a major role in all chemical bonds, which we'll be discussing later as well. They are very important in electronics as they create electrical currents. What is an element? An element is a substance made of only one type of atom, only one type. Elements cannot be broken down into different substances. They're one substance. Each element can be identified by its specific physical and chemical properties. What is the periodic table of the elements? You're going to get more familiar with this. The periodic table of the elements arranges all of the known chemical elements from left to right and from top to bottom in order of increasing atomic number. We'll be talking about atomic number later, but it has something to do with atoms because it's got the word atom in it. What are some common elements? So let's talk about some pure elements that have only one type of atom. So gold, and by the way, the little symbols here, that is the symbol on the periodic table for that element. So AU is the symbol for gold. You'll get familiar with some of these as we go. So gold is an element. Aluminum is an element. Carbon is an element. Oxygen is an element. Iron is an element. Notice that iron is Fe. And hydrogen is an element. So the periodic table has all the known elements. Those are just a few. What is a molecule? A molecule is a group of 2 or more atoms held together by chemical bonds. Many atoms can combine with other atoms. When atoms combine, they form a chemical bond. 2 or more atoms of the same element can form a molecule, or you could have 2 or more atoms of different elements. They can also form a molecule. Any combination of atoms is a molecule. So they can be the same or they can be different types of atoms. A chemical bond is a force of attraction between 2 or more atoms. And some large molecules are made of thousands of atoms. What are some common molecules? Well, water is a common molecule. Its chemical makeup is H2O. The H stands again for hydrogen. The little 2 stands for how many atoms of hydrogen are in the molecule. And O stands for oxygen. When there's no number by it, it means there's just one atom of oxygen combined in that molecule. So here's what it would look like. You have a hydrogen atom and another hydrogen atom there, and then you have the oxygen atom in the center. This one I forgot to put the animations in. What are some common molecules? Here's another one, baking soda. Baking soda's chemical name is NaHCO3. Na stands for sodium, H is for hydrogen, C is for carbon, and 3 atoms of oxygen. So here is the molecule of baking soda. You can see the 3 red ones are the oxygen, the black one is the carbon, and the purple one is the sodium, the Na. So you'll see there's 3 oxygen atoms there. That's what the little 3 stands for in the chemical formula there. Okay, what are some more common molecules? How about salt? Salt is sodium chloride, sodium Na, chloride Cl. Here's what sodium chloride looks like. There's your sodium molecule, or your sodium atom, I'm sorry, and your chloride atom. Together they form a molecule of salt. What are some common molecules? Here's another one, sugar. That one's a little bit more complex. It's actually glucose. 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Let's see what that looks like. There it is. And you have 6 carbon, they're the dark ones, the dark gray, black color. You have 12 hydrogen, they're the white ones. And then you have 6 oxygen, those are the red ones. So that is a molecule of sugar. Okay, this might be a good stopping point for a moment to pause the video, take a break, and come back when you are rested and ready to hear the rest of it. Okay, a compound is a substance made of 2 or more different elements that are chemically combined in a set ratio. A compound is represented by a chemical formula which shows the elements in the compound, such as CO2, that's carbon and oxygen, carbon dioxide. When 2 different elements combine to form a compound, the compound has different properties from the individual elements. Okay, when you form a compound, the properties of that change. So here's an example. This is ethanol. This is an example of a compound. Forgot to put my animations in this one too. So ethanol is C2H5OH. So carbon 2, that's a molecule, right? 2 atoms of carbon together. That is a molecule, and remember molecules can have the same elements or different. Here's a molecule of 5 molecules of hydrogen together. It's actually 1 molecule of 5 hydrogen atoms together, and then you have OH, okay? That is a combination of oxygen and hydrogen together, making another molecule. These 3 molecules combine to form a compound. So ethanol contains your 2 atoms of carbon, your 5 of hydrogen, and your 1 hydrogen and 1 oxygen bonded together. And ethanol has different properties from carbon by itself, different properties from hydrogen by itself, and different properties from hydrogen and oxygen combined. So it has different properties. A compound will always have different properties from its makeup. Remember what a substance is? A substance is an element or compound. Most things found in nature, however, are not simple elements or compounds. So what does that mean? So we have something called a mixture. A mixture is made up of 2 or more substances that are together in the same place, but their atoms are not chemically bonded. So here's some pictures of mixtures. Talk about them a little bit more now. I'm confused. What is the difference between a mixture and a compound? He's really confused. So she says, I'm glad you asked. So we're going to find out. Okay, let's compare. Compound on one side, this is our Venn diagram, and a mixture on the other. Well, both a compound and a mixture have atoms and both combine elements. Okay, what are their differences? A compound, the atoms are chemically bonded. The atoms combine in a set ratio. and a new substance is formed with new properties. I should underline that. So it's chemically bonded. They're combined in a set ratio, and new substance with new properties, okay, is formed. With a mixture, there's a picture of a compound. You have molecules of H2O, that's water. And with a mixture, the atoms are not chemically bonded. They are not chemically bonded. Atoms are not combined in a set ratio. They can be all different ratios. And each substance keeps its own properties. That is the difference. And there's a picture of a mixture. You'll see you have oxygen by itself and hydrogen by itself. They are not chemically bonded like they are on the left picture with the compound. Okay, let's move on. I'll clear my drawings. What are the two types of mixtures? Heterogeneous mixture is a substances are mixed together, but they are not chemically bonded to each other. And you can see the different parts. So mixed nuts would be an example. Each part keeps its same properties. So pecans stay pecans, cashews stay cashews, right? It is pretty easy to separate the parts again. So I could easily separate the cashews from the pecans from the peanuts, right? That's a heterogeneous mixture. The second type of mixture is a homogeneous mixture. Substances are mixed together and also not chemically bonded to each other. However, you cannot see the different parts. Each part keeps its same properties, and it's difficult to separate the parts again. So that's a mixture of flour and baking soda and salt and all the things you would put in to make ingredients for cookies, but you can't easily separate those ingredients out once they're all mixed together. That would be pretty hard. So that is a homogeneous mixture, pretty difficult to separate the parts. However, they are not chemically bonded. They keep their same properties. So you tell me, heterogeneous or homogeneous? Air, what do you think? It is homogeneous, yes, because you can't separate out the parts too easily. Salt water, what do you think? Heterogeneous or homogeneous? Yeah, homogeneous. It's not too easy to separate out the salt from the water. M&Ms, heterogeneous or homogeneous? Exactly, heterogeneous, because it's pretty easy to sort out the M&Ms by color. Okay, a few more. What about a lake? Heterogeneous or homogeneous? What do you think? Homogeneous? Yes, because you have a lot of chemicals mixed into the lake that can't be separated out very easily. But it's also heterogeneous. Think about all the plants growing in and a fish swimming around. So it's also heterogeneous. That's one that's both. How about chicken noodle soup? Did you say heterogeneous? Then you are correct. Okay. How can mixtures be separated? Well, mixtures can be separated by sorting out the parts according to their properties. That's pretty easy to do when you have a heterogeneous mixture, right? Like that cereal bowl up there with the different things. But with a homogeneous mixture like that coffee, it's pretty hard, but it can be done. So here are 4 methods. So here, one method to separate out a mixture is distillation. Separating the liquids by boiling them. The liquid with the lower boiling point will vaporize first, leaving the other liquid behind. So you'll boil up 2 substances, say, one substance will boil away quicker than the other substance, and that'll just leave the second substance there, and that's one way to separate. Another way to separate a mixture is evaporation. Evaporation is the process by which liquids change from a liquid state to a vapor or gas state. This is a great method for separating solutions such as sea salt. So there's an example of how sea salt, how they get it. So they take a solution of water and salt from the sea. The solution is heated to boiling point, and then the liquid is evaporated away, and what's left is the delicious sea salt right there. That's a way of separating out sea salt. A third way to separate mixtures is filtration. That is, a substance is passed through some kind of filter that allows fine particles while filtering out larger particles. So here's a mixture of sand and water in this picture. You can see the filter paper there. It's allowing the water to come through, but it's catching the sand. So in the end, you get the sand left and the water's in the bottom of the jar. So that's filtration. And the final method of separation is magnetic attraction. This involves holding a magnet near a mixture to pull out anything that is attracted to the magnet, such as metal. So here's an example. You have sand and you have iron filings. You mix them together. If you put a magnet by them, it'll pull out all the iron filings because sand is not magnetic and will not be attracted to it. Okay, now your homework. You're going to answer these questions on the Google Doc that will be attached to this video. You're going to explain what matter is. You're going to explain what a substance is and give an example, I should say, of a pure substance and a non-pure substance. You should describe the two properties of matter and give 3 examples of each property. And you're welcome with these questions to go back and re-watch the video or use your science book as well. Label the parts of an atom and explain the particle theory of matter. Explain what an element is and give 2 examples. Explain what a molecule is and give 2 examples. Explain what a compound is and give 1 example. And by the way, be very clear on the difference between an element, a molecule, and a compound, because you're going to get an assignment about that. And you're going to want to know the difference. And also you're going to define a mixture, name 2 types of mixtures and give an example of each type. You're going to explain the differences between a compound and a mixture, and finally explain the 4 methods for separating a mixture. So I would like these in complete sentences, please. And I believe that is our last slide. I will come back on here and hopefully I'm coming back on. Trying to, there I am. And so this will be on Google Classroom for you, and I would like you to answer all of these questions. See you next time. Bye.